Welcome. A divisibility rule is a shorthand and useful way of determining whether a given integer is divisible by a fixed divisor without performing the division, usually by examining its digits. What does this mean? A divisibility rule is simply an easy way for you to know whether a number will be divisible by another number. By integer here we mean positive numbers, whole numbers, right? So when you know these rules, you can look at a number and know whether it will be divisible by 2 or 3 or 4 or 5 or 6, etc. The benefit of knowing this rule is the fact that by just looking and examining a number, we will know whether that number will be divisible, whether a smaller number is a factor of that large number. Here are some of these rules. The first one is the divisibility rule for 2. If a number is even, or a number whose last digit is an even number, that is 2, 4, 6, 8, including 0, it is always completely divisible by 2. What this means is when we see a number, look at the last digits. If the last digit is even, by even we mean 2, 4, 6, 8, or 0, it means that number is divisible by 2. I have two numbers here, 126 and 157. How do I know whether each or any of them is divisible by 2 or not? I'll simply check the last digit of the number. In 126, the last digit is 6. Because it is 6, it means 126 is divisible by 2. In 157, the last digit is 7. Because the last digit is not even, is not 2, is not 4, is not 6, is not 8, is not 0. It means the entire number, 157, is not divisible by 2. The divisibility rule for 3. It states that a number is completely divisible by 3 if the sum of its digits is divisible by 3. Anytime you hear sum, what should come to your mind is addition, plus. So when we add the individual digits that makes up that number, if the sum is divisible by 3, then that number is divisible by 3. We have two numbers here, 122 and 324. Which of this is divisible by 3? We simply add the digits. In 122, we will say 1 plus 2 plus 2. That gives us 5. In the next number, which is 324, we will add together 3 plus 2 plus 4. That gives us 9. Now, looking at 5 and 9, which is divisible by 3? Obviously, 9 is, 5 is not. This means that 324 is divisible by 3, while 122 is not divisible by 3. The divisibility of 4. If the last two digits of a number are divisible by 4, then that number is divisible by 4. Example, the first number here is 728. The second number is 213. So we will look at the last two digits. In the first one, the last two digits is 28. Since 28 is divisible by 4, then 728 is divisible by 4. The second number here is 213. The last two digits are 13, which gives 13. 13 is not divisible by 4. Therefore, 213 is not divisible by 4. The divisibility rule of 5. Numbers which last digit is 0 or 5. So once you see a number, look at the last digits. If it is 0 or 5, it means that number is divisible by 5. Example, 1505 is divisible by 5. 1790 is divisible by 5 because it ends with 0. But 157 is not divisible by 5 because the last digit is neither 5 nor 0. This is pretty straightforward. The divisibility rule of 6. Numbers which are both divisible by 2 and 3 are divisible by 6. So a number that satisfies the rule for 2 and 3 will be divisible by 6. Remember that for a number to be divisible by 2, it must be even, meaning the last digit must end with 2 or 4 or 6 or 8 or 0. And for a number to be divisible by 3, the sum of the digits must be divisible by 3. An example here is 2346. So by looking at this number, we can see that it is even because the last digit is 6. And when we add the digits, 2 plus 3 is 5, plus 4 is 9, plus 6 is 15. And 15 is divisible by 3. So it means that 2346 is divisible by 6 because it is divisible by 2 and also divisible by 3. The divisibility rule of 7. If a number is divisible by 7, then the difference between twice the unit digits of the given number and the remaining parts of the given number should be a multiple of 7 or it should be equal to 0. So we will look at the unit digit of that number. We will multiply it by 2 and subtract that answer from the remaining parts of the number. If the difference is a multiple of 7 or 0, it means that that number is divisible by 7. Example is 175. The last digit is 5. When we have twice of it, that's 5 times 2, which gives us 10. The remaining part is 17. 17 minus 10 is 7. Since that difference is 7, which is a multiple of itself, every number is a multiple of itself, then 175 is divisible by 7. The divisibility rule of 8. If the last 3 digits of the number are divisible by 8, then the number is completely divisible by 8. So when we are given a large number and you want to know if 8 is a factor of that number, simply look at the last 3 digits. Example here we have 5120. The easiest way to know whether 8 is a factor of this or not is to check the last 3 digits, which is 120. When we divide 120 by 8, we will see that it is divisible. The answer gives 15. So it means that 5120 is divisible by 8. The divisibility rule of 9. It is similar to the rule of 3, the divisibility rule of 3. If the sum of the digits is divisible by 9, then the number itself is divisible by 9. If the sum of its digits is divisible by 9, then the number itself is divisible by 9. Example, 9189. How do we know if this number is divisible by 9 or not? We simply add the digits together. 9 plus 1 is 10. 10 plus 8 is 18. 18 plus 9 is 27. Since 27 is a multiple of 9, it means that 9189 is divisible by 9. The divisibility rule of 10. It states that any number whose last digit is 0 is divisible by 10. That's pretty straightforward. So you just look at the last digits. If it is 0, then it is divisible by 10. If it is not, then it is not divisible, no matter how large the number is, right? Example, 10,567 is not divisible by 10 because the last digit is not 0. But 10,500 is divisible by 10 because the last digit is 0. The divisibility rule of 11. If the difference of the sum of the alternative digits of a number is divisible by 11, then that number is divisible by 11 completely. What does this mean? The sum of digits in odd places, by odd places we mean the first, the third position, the fifth, the seventh, those are odd places, minus the sum of digits in even places. By even places we mean the second, the fourth, the sixth, the eighth, etc. If the difference, when you subtract the sum of digits in the odd places minus the sum of digits in the even places, if it gives 0 or a multiple of 11, it means that that number is divisible by 11. Example is 3,633. The numbers in the odd places, that is the first and third position, are 3 and 6. The sum of 3 and 6 is 9. The numbers in the even places, the second and the fourth numbers are 6 and 3. 6 plus 3 is 9. 9 minus 9 is 0. So, since the difference is 0, it means that 3,663 is divisible by 11. It's either the difference is 0 or the difference is a multiple of 11. Then that number is divisible by 11. So in this case, 3,663 is divisible by 11. The divisibility rule of 12. If the number is divisible by both 3 and 4, then the number is divisible by 12. So if you want to know if 12 is a factor of a number, use the rule for 3 and the rule for 4 to check. Please note that the both rules must be met. The conditions of the both rules must be met. For 3, we have that the sum of its digits must be divisible by 3. And for 4, we have that the last two digits must be divisible by 4. So if a particular number meets the both requirements, then that number is divisible by 12. Alright, please look at this classwork closely and do it. Just look at the numbers and then tell us whether they are divisible or not.